Any questions from students, please?
Sir, is that auxiliary port is the third one, sir? One is for uh, like the gases with the vaporizer will
See,
mix
that
in.
is another important safety feature in the machine, in the workstation, is that it will work without the need for switching on the machine. And in case there is a power oxygen supply failure, total machine failure, this will still supply the oxygen that is required, and it can give up to 10 liters. Okay, and that can be used for supplemental oxygen during regional anesthesia procedures. It's also, instead of having a long connection required from a wall outlet, this can be used for your regional technique. Supposing after spinal you want to give oxygen supplementation 2 liters or 3 liters by a nasal prong, that you can always attach to this and give the supply to the patient. And supposing at the end of the procedure, patient has started breathing spontaneously, and there is a delay in shifting the patient. At the time you want to supplement, you don't have to keep the flow meter on. You can use this auxiliary port and supply the gases to the patient until the patient is wheeled out of the theater.
And one more thing also, sir, you initially said about Miller's quotation quote that if the machine fails and troubleshooting later and oxygenation and
Yes.
ventilation first. So if the ambu bag is available, you can connect
Yes.
to this auxiliary oxygen port 10 liters
Yes.
and continue ventilation and oxygenation with the ambu bag. Till the new
That
working
is why
machine
it has got a
Okay.
separate DAS connection and a separate spare delivery. That is the advancement or improvement they have done it, so that patient is never denied of oxygen and he is not allowed to become hypoxic. That is the idea.
Sir, if at all the ventilator and the vaporizer is on, will the inhaled anesthetic flow through this auxiliary port or not, sir?
It will not flow
This
unless
auxiliary
you open. You have a control valve for that also, isn't it? So unless you open that knob, you will not get the oxygen flowing out through that. This circuit will never not come to the connection to this at all. It is a separate line. That is why it's called auxiliary port.
Okay,
It has
sir.
got a separate line from the any source of supply. Earlier it was only from the pipeline. Now they have given a tubing both from the cylinder and pipeline. So if the pipeline fails, the cylinder will supply, and that comes through separately without any connection whatsoever to the flow meter or vaporizer. Then
Yes,
only
sir.
it becomes auxiliary or additional.
Yes,
It is
sir.
not
Yes,
connected to the main machine at all.
Yes,
it
sir.
will deliver oxygen even when the machine is totally switched off, sir.
Yeah, that's
And one common question examiners ask is what is the difference between anesthesia machine and workstation?
that I think Vinita answered in the very first start of the lecture itself. She said it requires electrical supply. Workstations depend on both pneumatic and electrical operations. Whereas the older machine, what I showed you, the initial pictures of Boyle's machine, it is mainly pneumatic. It works only on the gas supply. It doesn't require any power supply at all. No electricity needed. Whereas the modern anesthesia workstations, the majority of the components are electronic, so they all require a power supply. Without that, it cannot function properly.
Yes, sir. Some examiners ask about what is static electricity.
Yeah, that is
What
very.
is static electricity?
Any idea who can answer that? Pratik, can you answer that on static electricity and how static electricity is going of importance in anesthesia?
Sir, inside OT we are using many instruments, so some charge gets accumulated in the surface of the instrument, or we can say
even
OT
linen,
table.
not only
Linen, yes, sir.
instrument, but linen. Yeah. Main common culprit is the patient's linen and the rubber wheels of the machines and the table. All these areas, they have some electrical charge, as you said, stored up. and they can be released. Okay, as the name
Yes.
indicates, static, they are now idle, but they can be kindled to become dynamic also. Okay, so in the olden days, when we were using ether and chloroform, trilene, all these things, they were all combustible gases or agents which can catch fire easily. So static electricity was of very, very great importance in the yesteryears to prevent a fire or explosion inside the theater, because these agents were used and they used to be let out in the open inside the atmosphere of the theater without a proper scavenging. So if there is a spark from this electrical charge, then the whole gas will get ignited and there will be a fire or an explosion happening. That is the time when we were very, very careful about preventing this static energy or electricity getting released to cause a spark. And they made all the wheels of the machine, table, everything anti-static, including the breathing circuit, which was made up of rubber in those days. And they were black in color with a yellow coating to indicate that they have more carbon to make it anti-static. That carbon will prevent that static electricity getting accumulated there. Okay, so but still even today this static electricity is important, because in the flow meter sometimes, because the bobbin is moving up and down, that rubbing action of the bobbin can stimulate this static electricity to get released. So what do they do that? How do they prevent that static electricity formation in the flow meter? Any idea?
Static
Anti-static tube.
They coat it with a substance called Croxtane, Croxtane, which is an anti-static spray. So during the time of manufacture itself, they spray it with a substance called Croxtane, Croxtane, and this substance will prevent this release of this static electricity. And there is another chemical called stannous oxide, Stannous oxide, stannous oxide. So these two are used inside the flow meter tubes, torque tube, to prevent the release of static electricity when the bobbin is moving up and down. Because there are a lot of questions that can be asked with flow meters. One thing is, how will you read the flow meter bobbin, how much is delivering in darkness?
Fluorescent background is there in the fluorescent background is there.
They were using a fluorescent sheet background to the flow meter, but nowadays what is the mechanism? How are they? Supposing you work in a vitreoretinal unit and the whole theater lights are all switched off and the surgeon is operating. I don't know how many of you have worked in an ophthalmic unit. In the vitreoretinal surgery, the whole theater will be pitch dark because the surgeon wants no ambient light at all to see the inside of the eye. So in those places, now we have a small lamp available in the manifold top of the flow meter, and you can switch it on and then see the reading and then switch it off again. It need not be continuously glowing. Okay, so you have a separate light for the flow meter assembly, and the flow meter tube has got what is called float stop, FLOAT, float stop at the bottom and the top. They may ask you what is the purpose of this float stop. Any idea?
Sticking above the bobbin is prevented by this.
So the bobbin does not occlude the inlet opening, as well as it does not get disappeared at the top of the manifold of the flow meter. Okay, so that is the purpose of the flow top, which is there inside the flow meter tubes. Okay, so I've spent almost 2 hours on that.